All right, so once again, for this one, the initial key is this diagram. We have these two flows of liquid that are supposed to hit the same spot. And they ask us, is that possible? Well, I just diagrammed this by having two sets of measurements. I have the vertical height to the hole, and then I have the height from the liquid down to the hole. Okay, so I'm looking at from the top of the liquid to the floor. I'm measuring with respect to either one of those boundaries. I'm measuring up to the hole from the floor, and I'm measuring down to the hole from the top of the liquid. I measure down from the top of the liquid because that gives me the velocity. That's how I get the velocity. But I'm measuring up from the floor because that gives me the time it takes to fall. And then it's the multiplication of those two things, right? So we have our time that it takes to fall times the velocity. I basically erased it, but yeah. The velocity that we gain from coming down. So let me just say something like this. And then that gives us our distances. And then our distances come out to be that ratio. In the end, it comes out to be this ratio here. And so the answer, of course, is yes. Can this happen? Yes, if this is true. And what will happen is if you have a really big container and you have the water very high, then when one of these, when the water's really high, one of the holes will go faster than the other hole. So like the streams will cross. Like one will go here, one will go, well actually, yeah. One will go like this and one will go like that. And then as it empties, they approach each other and then they'll pass and cross over.